Look closely at this macro footage as two layers of plastic bubble and fuse into one. This is a chemical weld. PVC cement acts as a highly volatile solvent that liquefies the plastic, turning separate pieces into a single, seamless object. Following 6 strict steps allows you to engineer a professional-grade joint that holds over 160 psi. To start, gather your PVC pipe and fittings, cutting and deburring tools, clean rags, purple primer, and solvent cement. Check your applicator dauber size before opening a single can. Using a small brush on a large pipe leaves the joint dry. The dauber needs to be at least half the diameter of the pipe to saturate the plastic before the solvent evaporates. A blowout-proof plumbing system depends on this time-sensitive chemical reaction. That reaction fails if the physical preparation is compromised. Step 1 is cutting the pipe. A chop saw or a standard hacksaw gives you a clean 90-degree angle. Ratcheting PVC cutters often crush and warp the plastic, ruining the perfectly round profile required for a tight fit. This diagram shows why that square cut matters. The bottom 20% of the joint provides the strongest physical bond. A perfectly squared pipe sits flush against the internal stop, while an angled cut leaves a dangerous wedge-shaped void at the base. Step 2 is deburring. Sawing leaves plastic shavings inside the pipe. If you leave those burrs attached, they act as permanent snags inside your plumbing line that collect hair and debris until the system clogs. You also have to bevel the outside edge. As this schematic shows, a sharp, unbeveled edge acts like a snowplow, pushing the cement to the bottom, starving the walls of fluid. A smoothly beveled edge glides in, allowing solvent to coat the walls evenly. Perform a dry fit next. Push the clean pipe down into the fitting. It should slide in snugly and stop about 1/3 to 2/3 of the way down. While seated, wrap painter's tape around the pipe to mark the depth. This prevents purple primer from running down the pipe later. Meticulous physical preparation, squaring, clearing, and beveling, separates a master plumber's permanent weld from a vulnerable patch job. Step 3 is priming. Purple primer aggressively softens the PVC's surface polymers, so they are ready to accept the cement. Follow a specific application sequence. Coat the inside of the fitting first, then the outside of the pipe, including the flat lip at the end, and then the fitting one more time. Step 4 is applying the solvent cement. The cement must be applied immediately while the purple primer is still visibly wet. Apply a generous layer of cement to the pipe, then the inside of the fitting, and then one more quick coat on the pipe. Brushing the solvent too thin causes it to flash dry before you can assemble the pieces. This stage is a rapidly closing window for a chemical reaction. Any hesitation allows the primer to dry, preventing the molecular bond from forming. Step 5. Assembly. Quickly push the pipe into the fitting until it bottoms out. As you push, apply a firm quarter twist. That quarter twist evenly distributes the cement across the softened plastic, filling any microscopic dry voids inside the channel. As you seat the pipe, you'll feel it trying to back out. This is hydraulic pushback. The tapered walls and the fluid pressure of the melting plastic act like a compressed spring. To defeat that pushback, hold the joint tightly together for 30 seconds. As the timer ticks down, the liquid molecules lock into a rigid, solid grid. Letting go early allows the pipe to slide out, creating a shallow, weak joint. Step 6 is to wipe and inspect. Immediately wipe away the excess glue and peel off your painter's tape before the solvent completely hardens. Physically overpowering that hydraulic pushback is the final, non-negotiable step to securing the joint's structural integrity. Successful welds have a distinct visual indicator. Look for a continuous, unbroken bead of hardened glue all the way around the seam. This ring proves there are no dry gaps or voids inside. The system now needs to cure. The joint reaches handling strength in about 5 minutes, but requires 30 minutes of curing before it can safely hold 160 psi of water pressure. Always verify the exact cure time listed on your specific can of cement. Check the label before fully pressurizing the water main. Mastering this chemical reaction and the 30-second hold results in a perfectly clean, permanent, and leak-proof plumbing system.